Shortcut for adjoint of a $2 \2 matrix. Welcome, everyone. Before we dive into today's new topic, let's quickly recap what we've already covered. In our previous lesson, we established the fundamental definition that the adjoint of a square matrix is found by taking the transpose of its cofactor matrix. Now, while this standard method is a universal rule, meaning it works perfectly for any square matrix of any order, whether it's a 3x3 or even larger, I want you to notice that applying this full process to a simple 2x2 matrix can actually be quite tedious and time-consuming. It involves finding several minors and cofactors, which opens the door to many small calculation errors. But here is the good news. Fortunately, there is a much more efficient, simplified shortcut. This method allows us to find the adjoint of a 2x2 matrix almost instantly, without having to go through the long-form cofactor process. In the next few slides, I will show you exactly how to apply this trick. Understanding the shortcut. Now that we've established that the standard method of using cofactors can be a bit tedious for smaller matrices, let's look at the actual mechanics of the shortcut. Suppose we have a general 2x2 matrix, which we'll call matrix A, defined with elements of B, C, and D, arranged in 2 rows and 2 columns. To find the adjoint of matrix A, which we write as A, you don't need to calculate cofactors one by one. Instead, you can simply apply 2 very specific structural changes to the original matrix. First, look at the principal diagonal, which is the line of elements running from the top left to the bottom right. You are going to interchange these elements, meaning you swap the positions of A and D. Second, look at the off-diagonal elements, which are B and C. For these, you are only going to change their signs. This means you multiply both B and C by -1. It is very important to note that you do not move them. They stay in their original spots. So, if we put this all together mathematically, the shortcut shows that the adjoint of matrix A is a new matrix where D has moved to the top left, -B is in the top right, -C is in the bottom left, and it has moved to the bottom right. In the next slide, I will break this down into a clear step-by-step procedure so you can apply it to any problem. Step-by-step procedure. Now that we've seen the general formula for the shortcut, let's break it down into a clear step-by-step procedure. This will help you apply the method systematically every single time without getting confused. To find the adjoint of any 2x2 matrix, just follow these manageable steps. Step 1. Identify the principal diagonal. First, look at your matrix and locate the elements running from the top left corner down to the bottom right corner. For example, in a general matrix with elements of B, C, and D, these principal diagonal elements are A and D. Step 2. Swap the principal diagonal elements. Once you've identified them, simply switch their positions. You'll move the element at row 1, column 1, to row 2, column 2, and move the element at row 2, column 2, back to row 1, column 1. Step 3. Identify the off-diagonal elements. Next, look at the remaining elements that are not on that principal diagonal. In our standard matrix, these are the elements B and C. Step 4. Negate the off-diagonal elements. Finally, you need to change the signs of these off-diagonal elements. This means if an element is positive, make it negative, and if it is already negative, make it positive. It is very important to remember. Keep these elements in their original positions, do not swap them. Once you've completed these 4 steps, you'll have your adjoint matrix ready. Let's move on to the next slide, where I'll show you exactly how this looks in a real numerical example. Illustrative example. Now that we have understood the theory and the steps behind the shortcut, let's put it into practice with a concrete example. Imagine you are managing a warehouse and you're working with a small system of linear equations to track the costs of 2 different products. The coefficients for these products are captured in matrix A now. As we discussed in the previous slides, we often need to find the adjoint of a matrix as a crucial step toward finding its inverse. Let's look at our specific matrix. Matrix A, which is a 2x2 matrix where the first row contains 3 and -5, and the second row contains 2 and 7. Let's solve this step by step, using the procedure we just learned. Step 1. First, we identify the principal diagonal elements. These are the numbers running from the top left to the bottom right. In this case, our elements are 3 and 7. Step 2. Now we perform the swap. We interchange these principal diagonal elements. So, the 3 moves from the top left to the bottom right, and the 7 moves from the bottom right to the top left. At this stage, our matrix looks like this. 7 is in the top left, and 3 is in the bottom right, with the other positions still to be determined. Step 3. Next, we identify the off-diagonal elements. These are the elements that were not part of our diagonal. Looking at our original matrix, these are -5 and 2. Step 4. This is a crucial step where we change the signs of these off-diagonal elements. Be careful here, as we will emphasize in our next slide regarding common mistakes. We only change the sign, we do not move them. Our -5 becomes +5, and our +2 becomes -2. If we plug these back into our matrix, it now looks like this. The top row is 7 and 5, and the bottom row is -2 and 3. So, our final result is, the adjoint of matrix A is a matrix with 7 and 5 in the first row, and -2 and 3 in the second row. It's much faster than calculating cofactors, isn't it? But before we celebrate, let's quickly recap the key takeaways to ensure you've mastered the concept. Key takeaways. First and foremost, please remember that this specific shortcut is applicable only to 2x2 matrices. If you are dealing with a 3x3 or any larger matrix, you must revert to the standard method of finding the cofactor matrix and then transposing it. To keep the process straight in your head, I want you to remember these 2 distinct actions. For the principal diagonal, think swap. This means the elements at position 1, and position 2 simply switch places. For the off-diagonal elements, think sign change. The elements at position 1, and position 2, stay exactly where they are, but you must multiply them by -1 to flip their signs. It is also important to realize that even though this feels like a magic trick, it isn't just a random trick. This method is mathematically equivalent to the full process of finding the cofactor matrix and then transposing it. It's just a much faster way to reach the same destination. Now that we have worked through that practical example, let's pause and summarize the most important points to keep in mind. Before we move on to some common pitfalls to watch out for, does that summary make sense? Common mistakes to avoid. Now, before we wrap up today's lesson, I want to touch upon some common pitfalls. Even though we've just learned this incredibly efficient shortcut, it is very easy to make small slips that can lead to the wrong answer. Let's look at 3 specific mistakes to watch out for. First, be careful not to swap the off-diagonal elements. A very common error is to swap the positions of B and C while you are changing their signs. It is easy to get caught up in the movement of the numbers, but remember this golden rule. Swap the diagonal and only change the signs for the off-diagonal. Second, watch out for changing the signs of the principal diagonal. I've noticed that students sometimes change the signs of the elements they just swapped. Remember, the elements on the principal diagonal, the ones at position 1 and 2, should retain their original signs, only their positions change. Finally, keep a close eye on sign errors with negative numbers. This is a classic calculation error. When you are changing the sign of an element that is already negative, for example, if you have -5, ensure it becomes +5. Forgetting this double negative rule is a frequent source of mistakes, so always double-check your arithmetic. If you can avoid these 3 traps, you'll be able to use this shortcut with complete confidence.